Lesson 3.5 covers an introduction to matrices. To help us introduce matrices, let's look at the following example. You manage a restaurant that has 2 branches. Each branch has 3 different work shifts: breakfast, lunch, and dinner. Each day you must give a report describing the number of people served per shift for that day. And the following is an example of a daily report. So I have a table where the rows represent the 2 restaurants. My first row represents restaurant 1, and my second row represents restaurant 2. The columns represent the shift that I'm serving. I've got the breakfast shift, the lunch shift, and the dinner shift. So at restaurant 1 for lunch, 480 people were served. At restaurant 2 for breakfast, 120 people were served. Well, another way to present this data is through a matrix. A matrix is just a rectangular array of elements or numbers. The matrix is similar to the table that we just saw. We just don't put in any row or column headings. We're not going to write restaurant 1, restaurant 2, breakfast, lunch, or dinner. If you have more than one matrix, the plural of the word matrix is matrices. So an example of a matrix, using the table above, we would just write the numbers. So row 1 is 139, 480, and 595. Row 2 is 120, 496, and 533. Well, each of these numbers within the matrix are called elements or entries. Each element is contained in exactly 1 row and 1 column, and we can use those rows and columns to label the position of an element. The rows and columns are also used to determine the dimension or the size of a matrix. When you're listing the size, you always list the number of rows first, followed by the number of columns. We separate these 2 numbers with the symbol X, which reads as by. So the matrix listed above had 2 rows and 3 columns, so its size would be 2 by 3. If we look at some examples, suppose I had this matrix. Well, the rows are always horizontal, so I have 3 rows. The columns are vertical. I have 4 columns. You always list your rows first, so the size of this matrix is a 3 by 4. In the next example, I have 2 rows and 1 column, so its size is 2 by 1. The rows are horizontal, the columns are vertical, and you always write the number of rows first. Well, let's look at equal matrices. 2 matrices are equal if and only if they are the exact same size and corresponding elements are equal. So let's look at some examples. I want to know, are the following matrices equal? So suppose I have the matrix with the first row is 1/2 5 and the second row is 0 6. And I want to know, is that equal to the matrix where the first row is 0.5 and 10 halves and the second row is 0 6? Well, first you look at the size. Each matrix has 2 rows and 2 columns, so they are the same size. Next you look at corresponding elements. So begin with the first position. So this is row 1, column 1. I have a 1/2 in my first matrix and a 0.5 in my second matrix. These are the same value, so corresponding elements there are equal. 1/2 does equal 0.5. In row 1, column 2 of my first matrix, I have a 5, and my second matrix, I have a 10 halves. Well, since 10 divided by 2 is 5, these corresponding elements are equal as well. In row 2, column 1, both matrices have a 0, And in row 2, column 2, both matrices have a 6. So all of the corresponding elements are equal. So these matrices are equal matrices. In the next example, my first matrix is a 2 by 2, but my second matrix is a 2 by 3. The second matrix has a third column that consists of 2 zeros. You cannot drop off the zeros. You have to leave them in. That column needs to remain. So the first condition for matrices to be equal is that they have to be the same size, and these are not. So the answer to the question is no, because these matrices are not the same size. The first matrix is a 2 by 2, and the second is a 2 by 3. Let's look at the next example. Are these matrices equal? The first thing to check for is to see if they are the same size. And both of these matrices are a 2 by 2. They each have 2 rows and 2 columns. So they are the same size. Next, you look to see are corresponding elements equal. So let's look at row 1, column 1 in each matrix. In the first matrix, in row 1, column 1, I have a 6. In the second matrix, in row 1, column 1, I have a -8. So these matrices are not equal because the corresponding elements are not equal. These two matrices have the same elements, but the order is not the same. The two columns have been reversed. If you switch the columns or the rows, the matrices are not equal. Well, in the next few examples, we're going to use some equal matrices to find the values of the entries in the matrix. So our first example, the first matrix is a 2 by 2, where row 1 is X and Y, and row 2 is 0 and Z. That's equal to the matrix where row 1 is 1 and 2, and row 2 is 0, 5. So I want to find the values for X, Y, and Z. Well, use your facts about equal matrices. I'm told these matrices are equal, so I know that they're the same size, which I can see that, but I also know because they're equal, corresponding elements are equal. So the X and the 1 are both in row 1, column 1, so those must be equal. So X has to equal 1. The Y and the 2 are in row 1, column 2, so they must be equal. So Y equals 2. The Z and the 5 are in row 2, column 2, so they must be equal. So Z equals 5. In the next example, again, I have two 2 by 2 matrices that are equal. So we're going to set corresponding elements equal. So in row 1, column 1 of both matrices, I have a 2x and a 10. So I know 2x equals 10. I solve for x by dividing by 2, and I get x equals 5. Next, let's look at row 1, column 2. In the first matrix, I have an x minus y, and in the second matrix, I have a -4. So I know x minus y must equal -4. I just found that x was a 5, so I have 5 minus y equals -4. Subtract 5 from each side, and you get -y equals -9. And if I divide by -1, I get y equals 9. Next, look at row 2, column 1. In the first matrix, I have a 3z, and in the second matrix, I have an 18. So I know 3z has to equal 18. If I divide by 3, I get that z equals 6. Now let's look at adding and subtracting matrices. The rules for adding and subtracting matrices are as follows. First, the matrices must be the exact same size. If the matrices are not the same size, you cannot add or subtract them. Once you determine that they're the same size, you simply add or subtract the corresponding elements. You add or subtract the elements or the numbers that are in the same position. So let's look at our first example. The first matrix is a 2 by 3, and the second matrix is a 2 by 3. We're adding these matrices, so I'm simply going to add the corresponding positions. So in row 1, column 1, I have a 5 and a 2, so I'm going to add the 5 and the 2. In row 1, column 2, I have an 8 and a -4, so I'm going to add 8 and -4. And I'm going to do this for each position. Now, the second matrix, I suggest you put it in your notes just so you'll see what we did, but you don't have to write this step out every time. So in row 1, column 1, I have 5 plus 2. In row 1, column 2, I have 8 plus -4. In row 1, column 3, I have -1 plus 6. Then for row 2, I'm going to have 0 plus 11, and then -3 plus 4, and then 10 plus a -5. After I add these, I keep my answers in that same position. So my sum of these two matrices gives me 7, 4, and 5 for row 1, and 11, 1, and 5 for row 2. In the next example, I'm subtracting matrices. I like to add one extra step to the subtraction just so the signs don't get confusing. What I do is I change my middle sign to addition, and I change all the signs in the second matrix. So I'm basically distributing that negative sign. So leave the first matrix the same. It stays 11, 15, -12, 0. And then I'm basically adding the opposite of the second matrix. So the -7 becomes a +7, the 25 becomes a -25, the 4 becomes a -4, and the -6 becomes a +6. Now I'm just adding the corresponding elements. So 11 plus 7 is 18, 15 plus a -25 is -10, and -12 plus a -4 is -16, and 0 plus 6 is 6. So now look at the next example. My first matrix is a 3 by 2. I have 3 rows and 2 columns. My second matrix is a 3 by 3. I have 3 rows and 3 columns. Since these are not the same size, I cannot add them. So you would just say they cannot be added because they are not the same size. The next concept we want to look at is scalar multiplication. A scalar is simply a number that's being multiplied by a matrix. To multiply a matrix by a scalar, you simply multiply every element in the matrix by that scalar, by that number in front of the matrix. So let's look back at our previous example of the restaurant. And suppose the owner set a goal to double the number of people served for each shift. I want to write a matrix to show the number of people served each day in order to meet his goal. So basically, I'm going to take the matrix, the 2 by 3 matrix that I had before, but I want to double everything. So I'm going to multiply this matrix by 2. That 2 that the matrix is being multiplied by is my scalar. So to multiply this, I simply multiply every number in the matrix by 2. So 139 times 2 is 278. 480 times 2 is 960. 595 times 2 is 1,190. 120 times 2 is 240. 496 times 2 is 992. and 533 times 2 is 1066. So this matrix represents the restaurant owner's goals. So let's look at a few examples. Suppose you're given that matrix A is the 3 by 2 matrix, 5, 9, 4, -2, and 0, -6. And matrix B is also a 3 by 2 matrix, 0, -3, 7, 2, and -5, 1. So if I want to find 4A minus B, I'm basically going to replace the variable A with that matrix and replace the variable B with that matrix. So I have 4 times matrix A minus matrix B. So I'm going to take my first matrix and multiply every element by the scalar 4. And I'm going to take my second matrix and the negative sign in front, treat it as a -1, and multiply every element in it by -1. So when I do this, I have the matrix 20, 36, 16, -8, 0, -24, plus the matrix 0, 3, 0, 3, -7, -2, and 5, -1. So to add these two matrices, add the numbers in the same position. 20 plus 0 gives me a 20. Since those are both in row 1, column 1, put the answer of 20 in row 1, column 1. 36 plus 3 gives me a 39. 16 plus a -7 gives me a 9. -8 plus a -2 gives me -10. 0 plus 5 gives me 5. And -24 plus a -21 gives me -25. Finally, we're going to use the same matrices A and B, but this time let's find 2A minus 3B. So I'm going to write this as 2 times matrix A minus 3 times matrix B. So multiply every element in matrix A by 2. And multiply every element in matrix B by -3. When I do this, I get the first matrix is 10, 18, 8, -4, and 0, -12. Then plus, since I'm distributing the -3, I change my middle sign to a plus. My second matrix becomes 0, 9, -21, -6, 15, -3. Now add corresponding elements. 10 plus 0 is 10. 18 plus 9 is 27. 8 plus a -21 is -13. -4 plus -6 is -10. 0 plus 15 is 15. And -12 plus a -3 is -15.